I'm going to give a shout out to the company I got my e-stop switch from. They're based in the UK, they're in Leeds. I bought it through eBay, and which was very straightforward, and the price was really good. Look at that, £22 for the complete e-stop switch, and they've included a circuit diagram so that you know which way to install it, complete with the terminal numbering on the switches. So that's far more than you get from some of the other suppliers, which are the same sort of product that's come from China, but they've taken the trouble to give you a proper invoice. £22 for it, or £21.95. A proper address, somebody you can go and contact. There's an email address there. And so I am very pleased with the service, fast delivery, that I'm happy to recommend this company. Fitting of e-stop and no volt release to a lathe. This is the thing I've bought. Rather than buying the separate components, I bought the whole lot in a box. It will need wiring, and the thing I need to just work out is the order of wiring. That's the no volt release, that's the e-stop. So I think what it will be is live and neutral into the e-stop, earth into a connector block to carry it through, and a tail to fasten to the chassis through a screw into this side of the no volt release, out of that side to the machine. And I've got some spade terminals. No, I haven't. I've got some spade terminals somewhere that will fit onto there. Now, the previous one that I bought was a flush mounting one, and I decided I didn't want to ruin the cabinet. By flush, I mean inset. So I've got one that plants on, which, although it projects a lot, I guess it means that the e-stop is easy to get to. Because at the moment what we've got is the classic Dewhurst drum reversing switch, off, forward and reverse, directly connected to a plug top, let's call it. It goes into the socket, and that's it. So obviously if it's on at the time that the power fails and the power comes back on, it will turn. That's pretty convenient. It's not far away to knock that off, and it's a drum switch, so whichever way you knock it, it will go off. So I mean, it's what's been used on these lathes for 70, 80, however old this one is, a long time. Anyway, so that's the project. Not a tricky project, but as I say, in this instance I bought the whole thing in a box, and I can give you the price of it. I think it was in the order of £30 for that, whereas on the other lathe I built up my own remote pod for the variable speed drive, because they were wanting £68–70 for a ready-made up pod, and you've got a relatively low-cost component there and there. 6 simple wires into there. You still have to wire it in, of course, and the box. So I don't think I paid much more than £10 for the 2 switches, and maybe £5 for the box. So by the time you've sorted things out, that makes a bit of saving. But for the other thing I have bought, that's an emergency stop for this lathe. I've got a spare e-stop switch in there, but rather than fit that e-stop switch to the other lathe, I decided to get the 2, and I have fitted a no volt release. I'm going to swing round quickly onto the bandsaw. There it is. It's a no volt release switch in there to replace the rocker switch with a funny plastic cover that would allow you to knock it off. It was just an on-off function. A little bit of hacking of the casing to get it in, but a fair bit of hot melt glue as well to get it in there. And the actual quality of it, that's a low cost one, it works, but the quality of that no volt release switch is really low, at least the casing. That looks better. That casing definitely looks better than, obviously can't take it out, but that is in a clear, a transparent plastic casing. You can see the little, it's a relay, isn't it? A holding relay in there, but not pleased with the overall quality of the plastic and other parts of that one. This one I'm pleased, very pleased with the robustness of that case, the thickness of the plastic. Now the drum switch was mounted here on this cabinet, but I got the bracket off another lathe so I could mount it actually onto the lathe itself. And so the 4 holes that took the drum switch are not quite the same centres as needed for this box. These cone bits from the likes of Aldi and Lidl are great for cutting larger holes in plastic. And in fact I've got some stepped bits as well, which I used on my other box to make a large enough hole, because the step bits go a bit larger than this. They're challenged when trying to get through 3mm steel sheet. And so I've had to move up from the battery drill to a mains powered drill and a chuck, which is just a bit tighter, because of course once it starts grabbing in there it tends to just strip the shank. I'm not sure what condition the shank of this is in now, but it's still quite hot. Ooh, yes, it's hot. Oh, not too bad, because it's been spinning in the chuck, therefore damaging the chuck as well as the shank of the thing. Anyway, so it's gently as a go. It's only got 2 cutting faces, so maybe something with a few more cutting faces would have done a better job, but that's all I have for making these larger holes, and I think they're large enough now for my cable to pass through. And I'm hoping that the plastic because the holes in there are smaller, provides a grommet type effect to protect the cable from the sharp edges of the metal. I'm going to deburr that now with a countersink bit. Deburr all the holes with a large countersink bit, so I'll get rid of the burrs, but again I'm not opening up, well, when that's screwed on flat there isn't room for a grommet in there, but we'll have a look at that, see what we can do to make sure that the insulation isn't affected in any way. Well, that's 8 crimp terminals done. So you got the push on spade connectors here, and then the open sort of fork connectors on the e-stop switch. I've actually tinned the ends of the wires as well before crimping them. It just made it easier for me, and give a good tug on each tag just to make sure that it's crimped on firmly, and then the 2 earth wires crimped together into this sort of tag, and that one's going to be earthed to the cabinet, but not, and then the lathe is bolted through to the cabinet, so it will go through to the lathe, but basically the cabinet is going to be earthed. And I don't know what happens inside the drum switch. I'll have that open at some time and hopefully find that there's an earth which earths the lathe itself inside the drum switch, if not inside the motor. So that's it now, ready to be put in. So the orange 3-core 15 amp cable, it's not got a plug on it yet, it's just a big hank of it that I've got in to the e-stop, loop through to this side of the no volt release switch, out of the no volt release switch, out to the drum switch. There isn't an A1 tag on this one, so there's no interlock provision. And as I say, I've got 1 bolt left to connect through there, and I've got the ground in. So I'm going to give it a try in a moment or two. Forgot to point out cheapskate grommets, and if you wrap enough of it around, this is gaffer tape, you also get cable strain relief. If you want any additional strain relief, then of course you can put a little bit of what do they call it, tie wrap. Put a tie wrap around the cable as well. But this, I've got that right thickness. Yes, got that the right thickness, so that it's acting as a strain relief on the cable, because I've wrapped it up thick enough to jam it in the hole. There it is, a shiny new e-stop switch on the lathe. Just a minor point, I was glad that I replaced the cable to the plug, because as I undid I was looking to undo the the live lead that was in there from the old wire. The terminal was not very tight, it was actually really quite loose. So it's good that I've been able to put a new bit of cable on there and tighten that up. Mind you, not as bad as a lathe I once bought, which was wired up with solid core, just the sort of cable that you wire up plugs and sockets with in a house, flat twin and earth, but you know, with solid core non-flex cable. There we go. This is now something that I feel a bit happy with, and it makes it look, while it's all clean and shiny and new, makes it look better. And I've got that e-stop, which is nice and easy to access. I keep moving it when I'm moving there, and my on-off. So at the moment, the switch is on up there. On, off, but I can also turn it off there. I did give a yank on the earth wires, and they came out of the crimped connector. So I had to remake that with a new crimped connector, but I hadn't soldered the wires before putting them in, because it was quite a tight fit. So the next time I actually ran some solder over the wires, put them in, and then crimped it, and then ran some solder down the other end. And the wires are not going anywhere. They're really solidly in. So I'm not the biggest fan of crimped connectors, because it's easy to not get them crimped properly, even if the crimping machine goes to its ratchet position, click, 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 where it frees off. And you choose the right size and colour of this for your cable. So that's for a certain millimetre diameter of cable. Can't remember what it is, but they have been chosen to be about the right size for the wires that I'm using. The final thing is, if you're watching this video and you're not confident about electrics, then get somebody in who is. I know people who can do machining are multi skilled and can do all sorts of electrics and electronics. Some are less confident, and so if you're wondering where wires go, etc., it's, rather than ask a question on Facebook or YouTube, better to either get somebody in who you're happy knows what they're doing, or get somebody in person to actually show you, because it's easy to get things wrong, make a mistake, put the terminals round the wrong way, i.e. inputs and outputs, get those mixed up, or get the order of the switching not quite right. You know, I mean, you've seen what I've done. The mains in goes to the e-stop switch first, then it's linked across to the no volt release switch. Then from the no volt release switch, it comes out and into the Dewhurst switch, which goes to the motor. And that's now working as it should, as far as I understand.